Hello everyone. In this video, we are going to discuss about programming 8051 timer. This is the block diagram for timer 0 with external input in mode 1. As we discussed in the previous video, the C and the T bar helps us to identify whether it is counter or timer. C1 means counter, otherwise C0 means this is timer. In this way, it is taken as 1. Now the counter input is given to one of the input of AND gate, and then TR0 is taken here. Then the output goes to the resistors here. The resistor is TH0, TL0. This is the connection given to in this way the connection is given to the resistors, and here we have TF0 goes high when FF is 0. That is, whenever the rollover occurs, the flag resistor of timer 0 goes high, okay, whenever FF goes to 0. Okay, that is, after counting from 000 till reaching FF, the count is okay. Resistor will be 0. If the count is exceeding this, again rollover occur. So TF0 becomes 0. So that's what is indicated here. This way the external input is taken in mode 1 operation. Now if we observe the same for timer 1, the same connection goes. Instead of TR0, we have TR1 here. This is for timer 1, and here we have TH1, TL1 and TF1. In the previous we have 0 here, timer 0, and this one is for timer 1. Okay, in this way the hardware connection will be there. And let's see the steps to program in mode 1. Set timer mode 1 or 2. Set TL0 and TH0 for mode 1 as 16-bit mode, and then TH0 is set, and then this is for mode 2 8-bit auto reload mode. Okay, these are the conditions which we want. Whichever we want, we can select that, and then run the timer. Monitor the timer flag here. So frequently we'll be monitoring the timer flag. This is the timer flag here. Now let's go into the coding. We are taking one example. In the following program, we are creating a square wave of 50% duty cycle with equal positive portion and low. Okay, positive and as well as a negative portion. That is, here the duty cycle is 50%. Here it is 10 months, here also 10. So equal proportion is taken. So only the duty cycle is taken as 50%. On the bit port 1, fifth bit, the timer 0 is used to generate the time delay. Now let's see. Initially the mode selection is done. So we are taking mode 1 for the 16-bit mode operation for timer 0. So we are sending that into Gmod, and then here we have low register value with low byte some count F2, and then high register value for timer 0 TH with FF, and then we'll be toggling here just to kill time. Okay, complement pin 5, we are toggling the value over here and just to kill time over here, and then for delay purpose a call is there. So call delay program is executed. This is the delay program. In this delay program we can observe that we are setting the TR0 here, timer register 0, and then jump on bit no bit, and then if flag register is not set, then it will be executing the same. If flag register is set, I already told you the condition. Whenever the rollover occurs from high value to 0, rollover occurs, then it will be 0. Okay, So at that time clear tr0 and clear tf0 and then return. It returns to the a call. Like this, jump here, the loop is made continuous. Okay, and then program ends. So this is the logic where we are producing high and low continuously. So the delay is mainly used to have this data. Okay, the data sends to the port and it stays until the delay is completed. So in this way, this is one of the example how the timer is programmed. And then we have another example where the timer 1 is taken. We are particularly measuring the frequency here. Crystal frequency is there around 11.0592 megahertz, and for timer 1 we are using P1.5, and 10 is taken, so that 10H is taken, so that the timer 1 in mode 1 is selected for 16-bit counting, and low byte value is sent, high byte value is sent, the timer register is set, and then the condition is checked here for flag bit. Then we are clearing the timer register, complementing this to high low like that, and then TF flag is cleared, and then we are going for repeating the same loop. Okay, so in this way we are going for high low like that. It goes here, we don't have any delay, it goes up down like this spike will come. Okay, if we are asked to calculate what is the delay, this is the procedure used. Maximum value is ff minus this twist value timer h, th1 and dl1 present in the coding is 34 here, and this one is 76 here. That value is subtracted from high value. We are having 89 cb plus 1, so cc. This is nothing but, in terms of clock, we'll get it as 35276 clock count, and that clock count will be multiplied into 1.085 milliseconds. So it is nothing but 38.27 milliseconds for half of the wave. So in this way we can calculate what is the time calculation for time duration for each wave. What is the time duration for time period for a square wave here? This is half of the square, it is only positive side. And what about the low? That also need to be calculated. It will be 50%, we'll get the same value here, and then that's what it is done here. It is taken twice, first high and then low. So 76.54 is the actual value in milliseconds, and the frequency can be found out, that is 1 by 76.548 milliseconds. So calculating this, we are getting the frequency 13.064 hertz. So this way we are producing the square wave. And what are the findings here? So let's observe what are the findings here. Values to be loaded into the timer. The crystal frequency is 11.0592 megahertz, approximated to 12 megahertz. Divide the entire desired time delay by 1.085 milliseconds to get what is n. Once n is obtained, from the high value you subtract n, you will get what is the count. Convert this count into hexa value. Once the hexa value is ready, set TL with the hexa value and TH with the hexa value. Low and high values are taken into TH and TL. Now let's calculate the timing frequency here. Once T is 1 by 50 hertz, we'll get it as 20 milliseconds. Half bit of it is high and half portion is low. So the timing will be 20 milliseconds high and 20 milliseconds low. Now 10 by 20 milliseconds, the time for the microcontroller is 1.085 milliseconds. So that is nothing but 9216. We have n value. subtract n value from 65536 minus 9216, and we'll get 56320, and in decimal convert that into decimal. We will be getting it as DC00H, and load that value into timer register. High value in TH, low value in TL. The calculation of 12 megahertz crystal uses the same steps. Now this is the coding done, the same coding, only the value in TL and TH vary. So generating large time delay. If we want a large time delay, we'll follow in these steps. Size of the time delay depends on crystal frequency, timer 16-bit in mode 1. Large time delay is achieved by taking both TH and TL0. What if that is not enough? So let's find out the procedure to calculate the time delays here clearly. For that, we can use Windows scientific calculator, which is available in our laptops, to find TH and TL values. Say for example, we have 35,000 clock pulse of 1.085 milliseconds. That is the time delay required. Open the scientific calculator and select the decimal there. Enter 3500 and select hexa. This converts hexa value. 35,000 hexa value will be converted, and we get 88B8H, and then select plus or minus to give minus to the decimal value here, and then minus 3500 decimal value, we will be having 7748H. So the lowest bit is 48 and highest bit is 77, is saved in TL and TH registers. So this is the way how to calculate the value for TL and TH. And we have another example which will execute delay here. The same procedure is used. You can just go through this. And once we have TL and TH, how to find out what is the timing? We are going in a reverse procedure. So once we have decimal value, that value is subtracted, n is known. After subtraction, we'll get some value. That value is multiplied with 1.085 milliseconds. So we'll get 70.82 milliseconds here. That is multiplied into 200. 200 is the value given here for the count purpose. That is the number of count here. And finally, we have 14.16 milliseconds. This is the actual time period of the delay. And about mode 0. In mode 0, it just works like mode 1 only. In mode 1, we have 16-bit register. In mode 0, we take it as 13-bit register. 13-bit register means we'll have maximum 1 FFF. Whereas in the previous case for 16-bit, we have FFFF. So this is the maximum value. Whereas in the 13-bit mode 0 case, we have 1FFH. This is the highest value. When the timer reaches this maximum value, it roll over to 0. And TF file will be set. And programming in mode 2. So let's see the conditions for mode 2. 8-bit timer allows value from 00 to FF. Since it is 8-bit timer, we'll have value from 00 to FF only. And then TH is loaded with 8-bit value. A copy of this is given to TL. Timer is started by set timer 0 or set timer 1. Timer 1 or timer 0, any one instruction can be used. Start to count up to incrementing the TL register. Count up until it reaches its limit of FF. When it rolls over FF to 00, it gets high TF. TL is reloaded automatically with a value in TH. To repeat, clear TF. Mode 2 is auto reload.